In section 3.3, you need to be able to solve systems of linear inequalities. And a system of linear inequalities is a set of two or more linear inequalities. And here are some of the inequalities you'll be using. And the inequalities have to have the same variables. In section 2.5, you graphed one linear inequality. And when you graphed the line, you had to decide if it was dashed based on these two inequalities, or solid based on those two inequalities, and also where to shade to indicate the solution area. In section 3.3, you're going to be graphing and shading with two or more linear inequalities, and the solution area will be where the shadings overlap. Okay, so let's do a couple of examples here. I'm going to graph two inequalities on the first example, and this indicates that my line will be dashed. So I'm going to go to 1, and that's my y-intercept, and my slope is -1, so I'm going to go down 1 over 1, and I'm going to go put points all the way across my graph, just because when we get to section 3.4, we're going to be concerned about vertices of the shaded regions. So the more accurate you are with your graph, the better your linear programming problems will turn out. So this is going to be dashed, and now I need to decide where to shade. And if I put my pencil on the y-intercept, this is greater than, so the values greater than 1 are this way. So I'm going to shade, and I'm not going to make it really, really dark because I have to do another shaded region. I need to be able to decide where those overlap. Okay, so I shaded above the line, and now I'm going to do the second one. Now we don't have an x here, but we do know that all of the y's are going to be 2. So all of these points right here have a y coordinate of 2. And I can see that my line is going to be solid. So when I draw that, now I need to decide where to shade. So again, I'm on the y-intercept, and I want values that are less than 2. So those values will be below here. And what I'm going to do is I'm going to shade in the other direction because I need to see where the two shadings overlap, and if I go the same direction, it might be a little hard to see. So I shaded below here, and now I want to darken my shaded area just to show where all the solutions are. Okay, we're going to check, and you can do this if just to check and see if your solution area is correct. I'm going to choose the point 1,3, and it's outside of the shaded region, the region that's shared here, and so it shouldn't work for both of them. Now let's check. If I do y is 3, so I want to know if 3 is greater than, and x is 1, so that would be -1 plus 1. Is that true or false? Well, 3 is greater than 0, so that works. Now I'm going to substitute it into the second equation. We don't have an x, but we do have a y, so I have to say, is 3 less than or equal to 2? Well, that's false. So this region is not going to work. Now I'm going to choose one inside here, and I'm going to choose 4, 0. So it should work in both of these. So my y is 0. So I want to know, is 0 greater than -4 plus 1? Well, 0 is greater than -3, so that works. And again, checking the second one, I don't have an x, but I do have a y. And so I'm asking, is 0 less than or equal to 2? And that is true. So it works for both of them. Now you could check this region over here as well, but we're just going to check the two. All right, let's go to the next one. This one is going to create a figure, and we have 3 different inequalities. So the first one, we're going to go to 1. Now be careful with this one because the scale on the y-axis is 2, but the scale on the x-axis is 1. So our y-intercept is at 1, and my slope is 2. So I'm going to go up 1, 2 over 1, 1, 2 over 1, 1, 2 over 1, 1, 2 over 1. All right, then I'm going to go back the other way here. So 1, 2 over 1, 1, 2 over 1. Solid. So my line is going to be solid. So there's a solid under here. All right, and then this says less than. So I go on the y-intercept, and I want the values less than 1, so they're going to go this way. And now I'm going to graph y is greater than or equal to -1. Oh, so I wanted to shade, we'll shade below here. All right, so go to y-intercept again, and now my slope is -1. So I'm going to go down 1 and over 1, down 1, over 1, down 1, over 1, and so on. So here I'll just go up 1, over 1, up 1, over 1, up 1, oops, that's not 1, up 1, over 1. Okay, and this says greater than or equal to, so I know my line needs to be solid. All right, and this says greater than, so that means if I put my pencil on this side of the line, I know the numbers greater than 1 are this way. So this way I shaded vertical, and I'm going to shade horizontal. Just above this line. And now the last one I have is x is less than or equal to 3. So we don't have a y, but that's okay because every value for x, doesn't matter what the y value is, our x is going to be 3. All right, and that one also is solid. So this one we shaded above. And this one we're going to shade, we want to go less than 3. So if I'm at 3, the numbers less than 3 are headed this way. So I want to shade, and I'm going to shade this one diagonally. And I need to find where they all overlap. So here's 2 shadings, here's 2 shadings. Where they all 3 overlap are right here. So I'm just going to shade that in, and I can see that the figure is a triangle. Okay, you have some questions on the back. Before I turn this off, I'm going to ask you, why did all the apples in the fruit bowl know each other? So if you can figure out the answer to that riddle, just send me an email on Schoology.